Lesson 11.1 is on square roots and irrational numbers, and EQ for this lesson is how are irrational numbers helpful in the number system. So I am sure you have heard of rational numbers and irrational numbers. Rational numbers are any numbers, and you can put it in a form of A over B. So it can be any number that can be represented using a fraction. So even if you have an integer, let's say 2, it can be represented into 2 over 1, and negative 3 can be written as negative 3 over 1 or 3 over negative 1. So we have established that rational numbers are something that you can write using fraction form. So irrational numbers are going to be the opposite. By definition, irrational numbers are numbers that cannot be written as a ratio of two integers. It can't be written as a fraction format. The decimal form of an irrational number neither terminates nor repeats. That means it's not going to end and it's not going to repeat its number. So for example, the most well-known irrational number would be pi because it does not repeat and it does not end. When we're working with square roots, we have to know certain perfect squares, which is going to be a square of an integer. So I want you to remember the perfect squares of numbers 10 through 20 because they're going to be very helpful. So I'll write them here so you can refer back whenever you're working with your homework and later on when we're working with special triangles. When you are simplifying square roots, you're going to have two different types of square root. First one is working with positive numbers. So simplifying, for example, square root of 144, and we have all those numbers on the top here that you can refer back to. And we know that 144 is going to be a square of 12. So the square root, which means what is going to be the number that creates 144, is going to be positive 12. Now, if you have a negative number outside of the square root sign, you're going to have the negative sign pulled outside and then find out the square root of the number inside of that symbol. So, for example, if you have negative square root of 81, you're going to put negative sign in front, and then you're going to find out the square root, which is going to be 9. So your final answer is going to be negative 9. We're not going to cover anything that has a negative sign inside of the square root because it's going to go into another topic with topics that you're going to learn in probably algebra class, algebra 1 or 2. So again, if you would remember the perfect squares on the left, it'll be very helpful because you don't have to find out what would make those perfect squares when you are working on your questions. Now, unfortunately, not all square roots are going to be simplified into integers. So we have to estimate the square roots when you have numbers that are going to be in between those perfect squares. When you're estimating square roots, what you're going to do is you're going to find out two numbers that are going to be on either side of your square root. And what you're going to do is you're going to put perfect squares that are close to that given number on either side. So one is going to be smaller and one is going to be greater. After you have those two numbers, you're going to compare those two distance and you're going to pick the one that the middle number is closer to. So for example, let's say we have a square root of 30. We have to find out which integer or which number is this going to be closer to. So I have square root of 25, which is 5 squared, and then I also have square root of 36, which is going to be 6 squared when you have the answers. And when you compare the answer, you're going to have 30 closer to 25 squared root than 36 square roots. So your number is going to be closer to 5 as a result. So you can write this as square root of 30, and you'll have the wavy equation sign to indicate it's about, and then you put 5. The part that I put the red arrows are to indicate the differences. So from 25 to 30, you have 5 difference, and then you have 30 to 36, you have 6 as their differences. So let's try another one. Let's say I have square root of 14. You're going to have to find two numbers that are going to be 1 less and then 1 greater than the number in the middle. So for square root of 14, the one that is less for the perfect square is going to be square root of 9, which is 3, because 3 squared is 9. And then 1 greater than 14 is going to be square root of 16, which is going to be 4 times 4, so 4 is going to be your integer. And when you compare the distance between the two, you can see that square root of 14 is closer to square root of 16, which is going to be 4. So you would write square root of 14 with the wavy equation sign 4. So the key point of estimating square roots would be finding two different perfect square roots and placing on either side of it to see which integer is going to be closer to the number in the middle. Now with this lesson, you have to watch out for one thing, which is when you have perfect square roots, you're going to end up having integer as your answer. So they're not actually going to count as irrational numbers. So if you see any square roots with perfect square, such as square root of 100, square root of 121, or square root of 256, those are going to be integers, which is going to be part of rational numbers. So first check if they are going to be perfect squares, and if they are, they're automatically going to be rational numbers. If you know that it's going to be in between numbers, like square root of 30, square root of 14, they're going to be irrational numbers because they're not perfect square, thus they're not going to change into integers. The last part for this lesson is solving for x. So you're going to have equations such as x squared equals 100, and you have to find two integers that would make this equation true. Whenever you have squared or cubed for the answers, you have to make sure that you have at least two answers. So for example, if you have x squared equals 100, then you have either positive 10 for 10 times 10, or you can have another one with negative 10, which means you will have to do negative 10 times negative 10. So as you can see that you have squared, so whatever the number you have, you're going to square it, you're going to multiply the number itself instead of multiplying something else. So the answer for this is going to be x equals 10 or negative 10. If you have x to the power of 3 or x cubed equals a positive number, you're only going to have a positive answer for your solution, because if you multiply negative number 3 times, you're going to end up with a negative answer. So for example, if you have x to the power of 3 equals 27, you're going to have positive 3 as the answer, because 3 times 3 times 3 will give you 27. But if I do negative 3 times negative 3 times negative 3, it's going to give me negative 27, which is not equal to what I want to find out. So for x cubed, you're only going to have one answer, as x equals 3. One of the questions that you'll have for your homework, you're going to have an equation similar to this. So I have 5m squared equals 125. What I'm going to do is I'm going to solve for m squared, and it turns into m equals something. And first I want to leave m by itself, or m squared by itself, so I'm going to divide both sides by 5. So when I do that, m squared will turn into 25. So if m squared is 25, that means it's going to be square root of 5, or because it has squared, I have also another possibility with -5. So my answers are going to be m equals 5 and -5. Your homework is going to be from lesson 11.1 practice worksheets that I will be uploading along with this. And if you watch this video all the way through, please draw a bear next to your name so I can give you some extra credit. Thank you.